So our goals today is to talk about wood veneer specifically, but also some technologies in wood veneer that you might not have been aware of. For example, slicing veneer to a micro thin 0.2 millimeter is unique. And it allows us to do things, technically speaking, with wood that, that you might not have realized. So the typical millwork industry is using flitch, which is sliced from the log, that is 3 times thicker, or 0.6 millimeter. And what that allows them to do is it allows them to stitch the veneer together, and then they assemble that to any sort of millwork cores. And we're going to go through all of those different processes so you understand what it takes to do a millwork project or a millwork wall, and then also help you understand what this micro thin or 0.2 millimeter veneer is in relation to it all, and then how in the end that's going to help you save your project, your client, time, money, and a tremendous amount of natural resources. So let's dive into what is this stuff. Well, it's the natural resource is clear, right? It's trees. And so it's the great renewable resource that we have now, but these trees aren't just any oak tree or any maple tree. These are the best of the best in the way that the environment that they were able to grow. The soil was right, the water was right, they weren't crowded in the forest. They had they weren't subject to infestation of insects. So they were likely in a very healthy, biodiverse situation for their entire life. And that tree may be a 40-year, an 80-year, 150-year species. And so, because this is such a precious tree, we want to maximize this resource. And so what you're seeing is the veneering process similar to most other veneering processes, with the exception that this is being sliced 1/3 the thickness, down to a 0.2 millimeter. So think of 2 pages worth of paper rather than 6 pages worth of paper. And then after we slice it from the log, it gets reassembled back into the way the log was naturally. And what that's called is called sequencing. So there's a lot of coordination in this slicing process, because we are paying close attention to the tree itself, the quality of the tree, the slicing of that log, reassembling it as it was sliced. And now we work with you, the specifier, to figure out how to assemble that. And that's what we're doing here, is we're overlapping the flitches based on your specification. So, and we're going to talk about that throughout the CEU, the different types of matches that we have available to you, and how that's going to affect the overall visual of the veneer sheet and the ultimate final wall or ceiling that you're working on. But this is a very visual process. So at every stage, we are looking at the tree, the flitch, the assemblance of the flitches into the sheet good. And so we live in the world of AIA architectural grade veneers, meaning that if there's impurities or characteristics of the tree that are not visually pleasing, that's another part of the wood industry, not the industry that we're talking about today. So there are B grade veneers when you start to get variances and impurities and things along those lines. But what we have here is certainly the opportunity for a high level of visual control. So let's talk about wood historically. You go back to ancient humanity, and wood was always part of our lives. And so there's always been a synergy, mostly a healthy synergy, between humanity and the forest. Whether it's allowed us to cook our food, heated us, or has created our housing or tools, etc. It's important that we keep a healthy synergy between humanity and the forest. Now, going back to utilizing wood as a decorative material, we're able to see that all the way back into the Egyptian days, right? Back into 3,000 years ago, where we've had tombs that have created some incredible artworks. Now, the Egyptians treated this, and the reason why they were veneering was because they treated it like any other semi-precious material that they were utilizing, like gold or stones. So why do we veneer? We veneer because it maximizes this precious resource, right? Well, that's one of the reasons, at least. So if we think of veneering simply as a maximizing of the resource, the hardwood, which of course is something that we like, I mean, we like that even the word hardwood is something that's appealing to us. A half-inch hardwood is going to consume 17 times more, at least, of that log if you're looking at 0.6 millimeter veneer. And that's not even considering all of the wastage that we end up losing when we start to convert that log into a timber, because there's a lot of wastage when we do that. Now, if we compare the micro-thin veneer, the 0.2 millimeter, then the half-inch hardwood is consuming at least 50 times more of that natural resource. Not to mention that one of the challenges in working with hardwoods is that because of the way the grainings move within that wood has a desire to want to move on us. So instruments like the guitar industry or the piano industry learned early on that veneering allowed them to make a better finished product because they were able to control it. So as time goes on, you have different technologies in veneer slicing, and you can imagine the challenges that we had in getting consistency and the quality of thinness in the very early stages of veneering versus the modern equipment that you saw in our video. So there's two sides of the extreme when we talk about forestry management, right? On one side, you have the extremists who want to be completely hands-off on forestry, and they prefer materials that are cradle to cradle, right? And if you use that logic, then you say, oh, well, I prefer to use glass, I prefer to use metal because it can be recycled. Well, that's great. The problem is that when we start to talk about those types of materials, they're incredibly carbon intensive materials. So they require a lot of energy to produce them, whereas the trees are, as they're growing, they are absorbing carbon. And then if we utilize that mature tree and we put that into some sort of finished good, then effectively that is the stored carbon that we move throughout our industries. And I think providing we do that in a sustainable way, and FSC, Forestry Stewardship Council, has been one of the mechanisms that the industry broadly has used to be cautious about, how we consume. So we're not, doing clear cutting practices, and we're aggressive in our plantings, and we are active more synergistically with the forest. Now, if we look at, where our factory is in Japan, we look at the cultural aspect of why this micro-thin veneer, and that is that you can go back to the term motanai, and motanai is like what I grew up with, which is a waste not, want not. And it's just, imagine you have an island ancient culture who has done extraordinarily well, especially if you compare them in the world marketplace, in understanding how to live within fixed resources. And so teaching that to your population at a young age of waste not, want not, or regret in waste is a great mentality to start with our youth. So it's so successful that we see this message being shared throughout the world, like in Africa, as you see there. Now let's talk about the technical aspects. Technical aspects of this micro-thin go all the way back, 50 plus years ago. And in this case, you see the 1970s, the Trinitron TV, which was the premium product of its time, all coming out of Japan. And this product, because of its price point and its quality, demanded a natural veneer on its outer skin. The problem is that when you do millwork with natural veneers and you put it into a shipping container and you ship that all over the world, that can be problematic for millwork materials and wood that wants to expand or contract or absorb moisture and give off moisture. The other challenge with a TV like this is it would get very hot. And so that sort of situation, would either the climate challenge or the heat challenge, would cause cracking or buckling or delamination. So the microthin veneer solved these issues and allowed this to be a successful product. The other markets that utilize microthin veneer and still do today are your automobile, because clearly we're not going to climate control our vehicle. And so it allows these veneers to be shaped aggressively also around these components. So why do we want wood? Why do we want natural wood? Well, we know and we've proven that it's a calming. You know, whenever we put natural materials, I mean, I enjoy having this natural teak veneer here in my kitchen. Certainly calms me when I'm at airports. Haven't seen one of those in a little while, but it's certainly nice when you can be in the lounge. You can have these natural materials like you see here at the Cathay Pacific Lounge at Heathrow Airport. So and I know that generally speaking, specifiers are purists. The question is, can they afford and can they get the consistencies when they're working with natural materials? And we're here to say absolutely yes. Now, when we start to talk about premium architectural millwork packages like the one that you see here, and this is one project that we're incredibly proud of. This is Alice Tully Hall. It's in Lincoln Center in Manhattan. And this is the standard, what you would expect in a millwork package, MDF core. However, there's, some added complexities here, like radius, aspects, but there's a high level of sequencing, meaning that as we sliced from this Moabi log, and now Moabi is an African species with a huge diameter, but we kept all of the slicings in sequence and then blueprint matched those veneer sheets across all of the different aspects of this project. Now, one of the reasons why we're so proud of this project is that over 2,000 sheets of veneer, 4x8, were utilized to complete this, and it was all consumed from only one Moabi log, which was really an incredible thing and still is talked about among the millwork community. Now, the other cool thing about this micro thin veneer is that we can assemble, we've innovated for this project, a translucent backer so that we can assemble it to various translucent core materials. In this case, it's a red acrylic, so that that light can transfer through. So, thus being an architectural millwork package, you can imagine that this was not cheap. And this was about $150 a square foot. So you're looking about an $8.5 million millwork package, and not everyone has the budget for that. So why is that sort of stuff so expensive? Well, I'll take you down the processes, because this is where I've spent most of my career. So the first thing you have to do is you choose your veneer surface, and again, we're working with the traditional 0.6 millimeter veneer. They're going to assemble those flitches based on how you specify it, and then that would go to some core material, whether it be an MDF or plywood, although the wall millwork industry would generally recommend an MDF because plywood's not good for flatness. And then whatever veneer you put on the face, you have to put on the back. That's called the balancing layer. And the purpose of that is to have the same expansion and contraction tensions on both sides of that core, so we maintain flatness in the panel. Now, after you lay up, is what they call that, or glue up that panel, now you have to edge that, you cut that to dimension, and then you have some sort of engineering, some sort of component that, like either it's aluminum or it's the French cleat like you see up in the upper right-hand corner, that allows this panel to be hung to the structural wall. Now, typically speaking, these panels have a weight of 3 to 4 pounds per square foot. What that means is that this has to be engineered. Your substrate has to be sufficient to support the weight of this system. And then the panels, as far as the cutting of these panels, require shop drawings. Shop drawings themselves are generally about 8 weeks or more and will not start until the deposits are made. So, inevitably, and we see this in construction all the time, that, the dollars are being held very late in the game, And then as you go through the construction process, monies seem to evaporate, and we're struggling for different ways to save time and money on the project. So, again, going back to curving situations in millwork, this all adds a lot of cost. So, if we take that $150 a square foot number, and I've seen millwork packages that go well over $300 a square foot, depending on the complexities and the species and so forth used. So there's a huge, there's a huge cost variance there. So here's another really, really cool auditorium. And it's still sequenced veneer, AA grade. And there's other really cool elements there, like those little holes that you see as little dark shadows. That's to allow the air and the sound to transfer into the cavity where we have rock wool behind there to absorb the sound. So this, even for us, for our standpoint, this would be considered a premium direct-to-drywall installation, but the final ticket price for this installed is only about $30 per square foot. So, from the client standpoint, they're happy. They're looking at a premium architectural veneer. They're looking at an amazing space, all these incredible attributes to them. But if we look at a direct-to-drywall application like this one versus an architectural millwork installation like Alice Tully Hall, we generally see about 1/4 the cost when we go direct to drywall compared to millwork. We're able to achieve a final result in less than half the time. And we are also looking at about 1/50th the consumption of natural resources. And one thing that is important to me, and I hope also eventually becomes important to you, is that we pay attention to the carbon footprint of all of the activities necessary to create the final result. And when we start to put that into consideration, then we have incredible savings in our carbon waste. So, this was a recent install we did in Los Angeles. And I think it's just such a cool final result. And if you create a requirement to the specifier or to the millworker and say, well, we want everything to be perfectly sequenced, but we don't want to see any seams. The vast majority of millworkers will tell you flat out that's impossible, because it generally is. Or they can do their very best to minimize the joint, but not really make it seamless. When we bond the veneer direct to the gypsum, as you see here, we are not burdened by the expansion contraction issues of the core material. So now we can take that veneer and we can make it effectively a visual seamless project. And when we are doing that in sequence, you can see that we're able to maintain a very high level of consistency, although we have those natural variances that really tell us that this is a natural material. Now, there are a lot of amazing synthetic versions, but I've noticed that when we start to put synthetic versions up onto our larger areas, they start to really scream at us as fake or false, because you see that repeat in the material, and we lose that psychological benefit that we want when we use the natural materials. So these are direct to drywall installs, and you could just even look by, the look of these spaces, that these are not new photos. These are projects that were done some time ago, very likely early 90s, I believe. And so, we're very proud that we have projects that are well over 35 years old. And still looking great. In fact, projects, casinos, where they've remodeled everything else around it except the wood veneer direct to drywall, because it's still so appealing. So let's talk about the different cuts. And these are some of these things you learned maybe in design school briefly, maybe you've forgotten. So we'll do a quick summary here. When we talk about flat cut or flat sawn veneers, it's that log which has been cut in half. And the visual of the grain has everything to do with how the blade slices in relation to the growth ring of the tree. And so you start with the pith, the very beginning of the growth of that tree, and then every season you have these lines, which is the seasonal change in the tree. when we are slicing the flat cut, we get a lot of cathedraling, a lot of activity. The flitch is a little bit wider because the raw material we're working with is wider. But when we want more of a linear visual, then we'll take that log and we'll cut into quarters, and then that blade will go perpendicular to that growth ring. So we get that linear slice, but now the flitch is generally half the dimension. Now, when we work with oak, and generally only oak, do we use the term rift cut. And the rift cut takes that same quartered sawn piece of the log, and now that blade is attacking the growth ring with the quartered piece on a lathe. So it's able to move on a radius, which gives us a very tight, linear, pleasing slice. The rotary cut is when you go and you look at commodity plywoods or commodity veneers. This is the lowest cost way to slice the log, and we can get the maximum yield as well. So, but when you look at the graining, they call this puddling in the wood business. But you will have a lot of variance here, and it's much more difficult to get any sort of consistencies. But there is a part of the wood veneer industry called reconstituted veneers. And what that does is it starts with a farmed raised or a common species like obeechii or poplar or birch. And then those will be rotary cut. They will take those larger sheets. They will stain some of those, okay, or all of those to certain colors. And then they will glue that back into a stack, maybe create some shapes or some interesting kind of things. And then they will re-slice that after they create sort of a man-made log, but at this point we call it a block. So for clients that are looking for maybe they want to imitate a premium species like ebony, recon ebony and a natural ebony are very visually similar. So recon ebony has a very high price tag. So recon ebony would be a cost savings. And it also takes pressure off of some of these premium species when we try to imitate them. Or we just create something that's just really cool, and we get clients when they want high level consistencies across large areas or multiple facets of the project, then they might choose a recon. So going back to naturals, after we slice the flitch, now it is how do we assemble that flitch? How do we take that slice and then create it across the sheet so that it will affect the visual dramatically. The book match is that mirror image that we see there, which is very commonly specified, but we do have to be careful because in certain species like maple and cherry, for example, but other species will do this as well, there's a very high reflectance value. So if you have a book match and now the light is reflecting in opposing directions, we will get this, what we call barber pulling. Now, I've actually had people ask me for this in their specification. So it might be part of your design goal to do this, but it's important that we all have these conversations early in the design phase so that we don't have surprises when it's installed and the client is scratching their head. So one way to avoid that barber pulling effect is just simply to slip match, and so we like this communication, through your local rep, Ann and Nancy here, seasoned professionals who are able to say, okay, what's your overall goal? So we share your overall goals. If you share that information with us, then we can give you the guidance of maybe what's a semblance or match would be right for you and your client. So now the random match is really not as random as you think, because what we do in this situation is that we create a formula, which you're very much a part of that process in creating that formula of how we pull the log apart and then reassemble it, okay, so that we get this this variance in the graining, in the coloration. Now, in certain projects, we've gotten really creative here. We've had certain clients that have intermixed maybe the same species from different logs, or the same log where they've done flat cut and then quarter cut. Maybe they take the flat cut and they alternate the direction so that you have a lot of, they call it a swing match. Or maybe you want to see a lot of real contrast there, so you integrate some of the sapwood, which is the outer layer of the tree. So we can have a lot of fun with that. Now, if we go back to like one of the projects that Ann showed earlier, where we had this very tall elevation and we wanted everything to have a high level of visual consistency and matching, then that needs to be communicated early, because we want to verify that you're specifying everything in such a way that we can in fact end match it. For example, you cannot do a random match, a semblance in the flitch, and an end match, but you can do a book match and an end match, as you see here, in which case sheet number 1 in the upper left and then sheet number 2 below it will, when we turn one of those sheets upside down and the bottom are together, now you have a mirror image also at the end of the sheet, not only side by side. So, but this all gets written into your specification, but there are some limitations that you might not be aware of unless you communicate with us. So once we slice the flitches, I mean, there's all sorts of cool creative things that we're able to do, right? So we can have fun with it and do sunbursts, but we've done really cool chevron patterns and things like that. This is called block planking, which is also really slick. And so if there's you know, anything you have in your imagination, just communicate it with us so that, you know, we can see if that's something we can do for you. And the production minimum is only 400 square feet. And, you know, if you look at a project like this and you think about, okay, if I'm not doing a wood veneer semblance like this, like we're discussing in our case, we can go direct to drywall or millwork. And you think about what the carpenter has to do. You know, you've got the plywood substrate here, that's going to have to be fire rated with certification. Then you're going to have a lot of different planking here that needs to be assembled. And we have to put, in that situation, a lot of control in the hands of the carpenter or the mill worker. And so that requires a lot of time, a lot of cost, and complexity that you may not have the stomach for, nor your client. Now, this is that impact project that Ann was talking about earlier with the ceiling application. Sorry, Ann, but I like these photos better. But these, what I love about this is you really get a sense of when we put the veneer direct to gypsum, the cost comes so tumbling down that we can put so much more of the wood in the project. And, you know, there are times in medical spaces, especially when you need to use a high pressure laminate, right? You need to use a high pressure laminate or things like that because you have a lot of chemicals in situations, and that needs to be down low where people are touching and a lot of cleaning elements are. But we need, especially in those very stressful environments, we need a pleasing and calming material. So, you know, very often people will send us a laminate sample to say, okay, these are the laminate elements that we have in the space. So match that to your natural veneer. And again, it's easy for us to do. It takes a couple of weeks. We get a control sample made for you, and we can match the species, the stain, and the sheen very often very close to that high pressure laminate. You can also see in that photo on the left where they contact cemented to the access panel. They could have done a much better job on that. That could have been done in sequence, but in this case, it shows that at least it can be done. So the ceiling was bonded using a clay-based wall covering adhesive, and then that access panel was bonded using a contact adhesive. You're gonna see more on this here through the class. But the other thing that's I think important to point out here is that you can do that ceiling with a veneer directed drywall for generally $15 a square foot or less. Even if you were to make a high pressure laminate panel and put that onto the ceiling, in my experience, that price point goes easily over $40 to $50 per square foot by the time everything is said and done. So, you know, it's one thing to ask your laminate rep, oh, how much for the laminate? But it's important to understand what it is as a finished component on your building. And that's not always an easy number to get from your mill workers because they don't communicate it that way. They communicate it as a finished number on the project. And this is why we see so much of our architectural millwork being VE'd out of our projects late in the game. And I hope that this is a solution for you. So this is Echo Condo. It's in North Miami. This project was completed about 3 years ago, and it's a recon. And if you look in the upper left of the photo, you'll see that you see what's called a pleasing end match. So recons are not formally end match that you like you see in a natural species, but we can do it in such a way that it is pleasing. And so this wall elevation was 13 feet. That's our maximum sheet dimension. So we did the end match at the factory so that all the installer had to do was step up on a stool, drop this sheet from ceiling to the floor. The sheet good is 3 foot wide by 13 feet long. And what's interesting also about this project is that it was all completed by one human being who was a loner, didn't want to have a helper. So this was literally a one-man paper hanger job. And it was 1,600 sheets and was completed in about 2.5 months. So this was about, we're guessing about a $13 installed a square foot final price point to the general contractor. So very cost effective. And when you go around that corner, it's a football field long, which is why this client chose to go with a recon, because there was so much of the veneer across so much of the space that they wanted a high level of consistency. Now let's look at how does this stuff get installed, right? So what you see there is the Roman clay-based adhesive. That's the brand we recommend, but there are a few others out there. And all of the sheets have a number on the bottom of them. So we know where the sheet falls within the sequence of the production. And most of the time, especially for large projects, we are producing the sheet good for that project. So the width is exactly what's the best width for the installer of the project. The length is what's right for the project. So it could be a 3x8, it could be a 4x13 potentially, which is the maximum we can do. And then we know what log it came from in case we need to add to that project because somebody didn't calculate right. Well, that happens. So we get the primer, which we recommend in every project, or some experienced installers like to prime with the adhesive itself. So that's called sizing, and that would be the day before you would put the adhesive, the clay adhesive, on the wall surface itself. So you have two adhesive layers touching each other. So once the adhesive makes its way into the back of the sheet, it has a curing time, or what they call in the glue business, an open time, which allows for ease of workability. So it means it can move around on the job site. And what we're going to see here is the Dalmar Hotel being installed, which is in Fort Lauderdale. And forgive me, a lot of these project photos are in Florida because I'm here in Florida. We're here in Florida. So it's very easy for me to bop around and take pictures here. So what you just saw there was the double cut. Okay, and we're going to see that a little bit later again in the video of where we can take the veneer flitches, they overlap them, and then we take the blade and we slice it down the overlap, and then pull out the scrap and then reassemble it, and then just clean up the glue residue. So that, again, that's how we get that seamless look. And it's just simple as dropping that razor blade over the veneer, being careful not to cut into the drywall as well. So there's a bit of skill there, but this is a skill set that is the wall covering hanger, not the carpenter. But when I think back in my history in the millwork industry, when I was responsible for millwork wall systems. Projects like this were always very time consuming, very expensive, because we would have to have a shop set up somewhere on the job site with a table saw, routers, guys who knew how to do complex measurements and then move it to the panel where they would cut them, carry that panel in place, secure that panel in place using any number of Z-clip system or perimeter-based systems. There's a lot of different things out there in the marketplace. And then forget about scribing. I mean, forget about tucking it into the corner and getting it exactly so that it follows the alternating shape or moving shape of the ceiling. So, because that would be too expensive in millwork. I mean, I saw our carpenter or installer do that here on my own cabinetry, and it's a very time-consuming process. So here, look, all it is you tuck it in the corner and then you run your razor blade across it. So we take all of that complexity, all of that equipment, all of that time, not to mention the dimension that you add to the corridor, because remember, the millwork panel is at least a ½ inch thick. Then the Z-clip system is at least another ¼ inch thick, but usually there's another furring system behind that that's another ½ inch thick. So you've got all of that buildup on your subwall that's eating up your corridor. Not to mention you have to be mindful of all your fire ratings. So, but even the other little challenges that become problematic for the millworker, like the wire that just came through the wall or the outlet that Oscar is cutting out right now. So things that are very time consuming, and also one of the areas that were my common claim, because if the electrician got their hands on cutting around the outlet, inevitably they wouldn't do a good job of it. I'd have stress cracks going off from the corners of the outlet, or some big ugly gap to the finish plate. So, what's cool here is that the tool is limited to a stool, a bucket, a straight edge, a razor blade, a sponge, a table where you can roll out the glue. And Oscar and his assistant are able to complete an entire corridor of this flat cut walnut in sequence through all these complexities in a matter of a day. So, as your clients are looking to you for solutions to say, well, I want a premium material here, I want a natural premium material here, how do I afford it? How do I get it in quick? I don't have time. I think this really hits all of those key points. Now, here's another example of him doing the double cut, which opens up not only just solving this particular problem, but being able to do the overlap and double cut is an opportunity in design, because now we are no longer at the mercy of the dimension of the sheet good, right? So the dimension of the sheet good is in the millwork industry is most common 4x8 or 4x10 or rarely 5x12. Then you have to have a seam or a joint or reveal or things like that. Whereas now we get to play with those visual reveals, maybe with the drywall reveal, or not have that reveal. So it just opens up our ability to control the visual here. So, so now we're going to see, he's got the overlap. He's going to take his straight edge, and you can see it's even just free flowing, just cutting down that overlap, pulls out the scrap, and pops it back down. Now, every now and then, people ask me, what are the things that can go wrong? Well, the one thing, probably the most dangerous thing in this is when the GC is rushing the whole project and the mud is still not even dry. Okay, so they've floated out the wall, but the mud is not even dry yet. Clearly, that's not going to make for a successful installation. Luckily, we don't get to see too many of those, but that is one issue. Sometimes the other issue is maybe the glue didn't make it all the way to the edge of the sheet. They got a little lazy in that area, or maybe they pushed really hard and some of the glue squeezed out. So in those situations, actually the repair is pretty easy. The glue manufacturer has syringes, so you could always insert some adhesive after the fact and get it to bond back down. So and I love when products have the allowance for mistakes in repairability. And I can say that this product allows for that. Now, the crucial part of the subwall is that it's a 4 or a 5. For sure, the better the quality of the substrate, the better the overall product. And it doesn't add that much to the cost of the finished overall project. So, so just, spend the extra money. Thank you, Oscar. I'm going to move on to the next slide here. And he did a great job, but the subwall was a 4, it wasn't a 5. And even in some areas I saw 3. So when I look at the Echo Condo, which we showed you with the pleasing match and match recon, is flawless. Here, you know, with my trained eye, I'm able to see some impurities in the subwall, but everybody was kept to super tight budgets, and overall the project looks amazing. And they did it on a tight budget in a very small time frame. And I know that that very often is a challenge that you're faced with. So these types of projects are everywhere. They're all over the world. And no matter where your client is and they say, hey, where can I go see this and such, we're very likely to be able to find a place where they can go and they can see a project that's been up for a while. Now, okay, so we've seen a premium architectural millwork installation. We've seen directed drywall, but here's another situation where sometimes your substrate is weird, like a metal fire door, and yet you want your veneer to flow in sequence, right? You want everything to be in consistency as far as the visual, the way the grains are going. So what we're seeing here is the very um, simple process. And I know it may, if you've never done this, it may not be simple to you, but really once you do something like this, even in your garage, it's amazing. I've made furniture in my garage or my driveway using contact cement. And it's simple. You spray the surface, the two surfaces that you're going to bond, you wait for them to dry, and then you have what's called a slip sheet here. And that's just, in this case, corrugated cardboard that's going to separate those two materials. And then you pull it out of the way, and then you just make contact, and you have an excellent bond. And contact cement is pretty much every handyman knows how to do it. And the other cool thing is when the micro thin veneer is that with a little bit of moisture, it takes on the structure of the aluminum sublayer. So what makes this work so well is there's an aluminum foil sublayer behind the veneer that really creates the structure there of the veneer. And we're able to fold over those hard 90 degrees, providing we're parallel with the grain. And then the trimming is literally a razor blade. So these are skills that you've learned, no doubt, at some point in your life in arts and crafts, or I'm sure when you were building models in your design schools, you know, you got very skillful with the razor blade. So this is really the skill set you need to be good at this type of installation. And that again mentioned, as I said, that micro thin veneer allows us to fold over the outside corners of those outside walls. So the aluminum reveals, there are many different products out there on the market. This is a Fry-Reglet product, which is a two-part system where it gets bonded to the subwall, and then this clicks in over the top of that. And one of the questions I get often too is, well, what about corner guards? I need to put a slide in here at how good we're able to wrap the corner guards. Just like we wrap that door, we can wrap the corner guards, whether they're metal or plastic, with exactly the same veneer and contact cement, so that you could just take a clear silicone and bond those into place, make a bunch of extras so that when need be, you can just pop those, remove ones that are damaged and pop new ones into place. This one's in Dallas, but after, you know, almost 10 years of use, it looked amazing. So, you know, corners are obviously a function of where it's used. Now, Fry-Reglet's one of the suppliers that talks up our product. We talk up their product. Why? Because they've got some cool systems here. And what I also do like to show there is that, you know, this is their showroom in Los Angeles, if you're ever over there. Notice that how well the seam is when we're working with the veneer in sequence. So it just means that that panel above the coffee table can be really whatever we want it to be. I mean, and so super easy, very affordable to do this installation in this way. And then another challenge that we see, and we see this in high-use public environments, is what about impact, right? So as far as scratch resistance and stain resistivity, you're going to get the same results from an architectural millwork package, because we're still talking about wood veneer, we're still talking about urethane. The cool thing is that wood with urethane can be repairable, and so the furniture repair guy can do really quite wonderful things and magical things with this stuff if something happens. But this is the mock-up we did for Gatwick Airport, which we were specified on, and hopefully will be coming through here shortly. And so we're using an FRL, or fiber reinforced laminate, as a high impact interlayer in sequence, so that we have that impact issue down below. But one of the other solutions to deal with that is to just go with high impact drywall. So there are a number of different ways that we can deal with that challenge. So, I think one of the things we're going to see because of COVID and unfortunately a lot of businesses that are going to be shifting their real estate situation. This is Paldeo, bonded directed gypsum with a little bit of cool carpentry to go around it. Now, our customer service folks did this install at our office. And it just goes to show you that you don't need shop drawings. You don't need to go through a whole lot of complexities. A wall covering installer without any permits and a carpenter can do amazing work. So, and that's what you see here again. After this one was after about 12 years of use in a high traffic North Miami, LA fitness. And this is the budget plastic reveal. So you see the plastic reveal on the right, the aluminum on the left. And here's another cool project where in this one, it's a flat cut teak. This is in Toronto. And we actually folded the veneer into that void, that reveal that's in the drywall. And if you look over the upper right of that doorway, you can see how well it end matched there. So it's just, this project was over budget and likely to be kicked out as a millwork package. As a directed drywall alternative, it saved the project 60% from its original quotation as a millwork. And you can see how good that looks even when we get close up to it and how easily it folds into that void. And then when you get to the end, you do need to cut that with a razor blade. And in this case, they used a little bit of a colored silicone to finish that off. They did a great job. This is another project done by your distribution group, Ann and Nancy. I don't think this one was yours, and I forget what the name of this project is, my bad, but it's just an incredible project. So ask your reps afterwards about this project if you want to go see it, but amazing end result. And getting veneer bonded to the ceiling is just makes it easy, it makes it cost effective. And then we can also micro perforate the veneer very easily and cost effectively so that when you need sound elements or sound reducing elements in the space, the fiberglass and the other core options that allow for sound absorption, they're easy to engineer, they're very affordable, and they're easy to put in sequence of the other elements that you have in the project. So this was made out of gypsum, this ceiling element, but it could have also been done out of acoustically absorbent fiberglass material. This one is bonded to the plywood pocket door, the MDF frame, both using contact, and then the same veneer direct to drywall using wall covering adhesive. So radiuses and on-site type installations to get everything in sequence just become much more simple things to execute. And then digital print opens up a whole nother opportunity, right? So we can sequence that, or we can look at doing inlays if you have the budget for it, but more and more digital print, which you see on the right there, is a more cost-effective way to get the look of inlay. But we can have a lot of fun with inlays and just make something really specific to the client, maybe that meets their corporate identity or something like that. So what I'm showing you here is the fact that although you may have a binder on the shelf and although you may have a sample set, in the end, our raw material is over 100 different natural species. And then these species can be sliced per your specification, as we've spoken about, flat cut, quarter cut, rotary cut, and then they can be assembled in any number of ways. It can be stained and finished in any number of ways. So ultimately, this is a product that is made to your demands with a production and turnaround of generally 6 to 8 weeks. But you have a product that's ready to install after 2 days of acclimation. So it is a, you know, if you compare it to the millwork challenges, it can be a lightning fast way to put wood into your project. And then we can have fun with things like block planking, add knots, or we can put those really cool translucent backers on there and incorporate them into glass. So these are the two guys. You got a wood expert and you got a glass and acrylic expert there on the left. And there's Tom on the right, our owner. And so what happens is, and the reason why I'm showing you this is because, you know, this is when the expertise are brought together to bring to further our abilities to mate materials and achieve end results. So, and that veneer and glass is amazingly affordable, by the way, and super cool looking. And if you're looking for extreme hygiene in wood veneer, that's one way to do that. The bonding veneer to aluminum substrates or metal substrates, like you see there in that ceiling, this is when you know you're spending too much on your latte. And in fact, they loved it so much they did it again in Tokyo. So the first photo was Beijing. And those are actually micro perforated ceiling tiles to allow for acoustic to go. And then also, you know, sometimes clients are struggling with climatic challenges. And when we take the veneer and we use the right glue with the right substrate, in this case it's aluminum or ACM on the left, then we can offset much of those challenges in humidities and also some engineering challenges. So again, just share your goals with us. CITES, you know, we talked about FSC, and we'll be close to done here, guys. FSC, Forestry Stewardship Council, is one way to manage our ecological consumption of wood, but CITES, in my mind, is even more important. So CITES, as you see here, is the Convention on International Trade in Endangered Species. This is what legitimate governments and legitimate companies pay attention to as to the consumption or the overconsumption of certain species. So if the Tamo ash burl is being overconsumed, then we get a red flag from CITES that says, red flag, we as a factory choose to stop promoting that to you. But also when it goes to a level 1, then it becomes illegal to trade that species across border. So you might also know, like Patagonian toothfish, AKA Chilean sea bass, was one of those things. And all they do is they switch the species. So instead of using Tamo ash, use Japanese sen. It's a simple adjustment of a subspecies or an alternate species to give you effectively the same taste visually or so on. So here's another project in Los Angeles, you know, again, directed drywall in sequence type installations, which visually are just amazing and amazingly affordable and easy to do. So just a quick surmise, I mean, these are generally 1/4 the cost of millwork, can be achieved in about half the time. And in sequencing, you know, I mean, sequencing is so important. This is a project, luckily I was not involved on, but, you know, this is when the specifier just merely said, hey, I want walnut architectural millwork panels. And that was a green light for the fabricator to pull the walnut sheets from whatever supplier. And that means you've got a hodgepodge of quilt work. And installed price on this is generally around $45, $55 installed a square foot. When you're talking about non-sequenced millwork, make it sequenced, the price doubles, almost immediately doubles, just by including that word sequenced. So, so that's where, you know, just be very mindful on that. Include that word in your specification to solve and prevent those problems from, you know, popping up at the end of the project, which is very ugly. Now, this is MCC. It's a university. It's in Rochester, New York. You know, again, this was where they took advantage of having the dimensions of the panels to be whatever they want them to be, and to keep everything in budget, because Rochester doesn't have $150 square foot or more for millwork packages. You know, all this was direct to drywall. Even those ceiling elements that you see there, those were all built to drywall. Then you got to put the reveals wherever you wanted to from a visual standpoint. And this whole project was completed extremely cost effectively. I think it was under $200,000 with all materials and installation completed, and with an amazing end result. So guys, that's our class. I want to especially thank